Hello, I'm Chris. Welcome to this talk on Faversham Creek. When I first came to the town, I was curious about this creek, a narrow, winding waterway, and how it became a Cinque Port limb. Among the many questions are, how did the creek function? How did it work? And did it affect the way people and goods moved through the landscape? Has the creek shaped the town in some sense? And if so, how? And where was the centre of activity? We know that in past times goods and materials were shipped from the creek to support the growing economy of London, like bricks, fodder for horses, hundreds and thousands of horses that form the basis of the transport system in London, and beer, and to fire the nation's ambitions to be a world power, gunpowder. And these materials were widely available locally, but not particularly valuable. They were needed in London, and it seemed that their value would magically increase just by carrying them from A to B. This was heavy stuff, and it wasn't easy to move because the roads were dreadful. Carts got stuck. Much better to carry it on boats on the water. It was much quicker, and it wasn't just a question of speed, because a 50-ton load on a barge was the equivalent of what, 50 wagons, 100 horses maybe, and 100 drivers. But first you've got to get it to the water. How can you move stuff from its origin inland down to the shores of the Thames estuary? Well, some of the journey takes place over land and the rest by water, but the quickest route, turns out, is not a straight line. And it turns out that the geometry of the route obeys something called Snell's law, which is the law that governs the way light moves through different media, that it travels through at different speeds, for example, like glass and air. And it's all about the angles, the angle at which you approach the interface between land and water, and the angle at which you leave, θ1 and θ2. And that relationship is governed entirely by the speed at which you travel over land and the speed at which you travel over water. And in this case, your boat is going to turn and head towards London parallel to the shore. So θ2 is 90 degrees. And we want to know, okay, what's the correct approach angle? And if you make a simple assumption like the boat travels twice as fast as a cart travels over land, then it turns out that the approach angle is 30 degrees. But the shoreline isn't straight as I pictured it in that last slide. It's indented with tributaries and creeks with smaller streams branching off them, a sort of fractal system. And this is what the most significant tributaries look like on the south bank of the estuary upstream as far as Dartford. Many of these tributaries are narrow and winding, but if there's enough depth, you can sail along a tidal creek quicker than you can pull a cart over land. In fact, the creeks and tributaries form a network that penetrates the hinterland. You see, look at the diagram at the top. The dark green stripes show it runs along the waterfront, and it's a relatively small area that's accessible for loading materials onto boats. But if you take into account the rivers and tributaries, as in the lower diagram, you suddenly open up a much larger area, and the land itself becomes more valuable. It attracts more investment and becomes more productive. So you can use the tributaries to get to the waterfront more quickly. And each one has a catchment area, which we'll see in the next slide. And it turns out that the catchment area isn't symmetrical. And the catchment area in this diagram is shown in light green. And you can see that the area to the right, that's on the eastern side, is much larger than the area to the left on the western side. We're looking to find what is that angle alpha. And here's the calculation. It turns out that the angle, if you take the speed over water as twice the speed over land, the angle comes out to 15 degrees. And what all this amounts to, whether you believe the numbers or not, is that you'd expect a greater proportion of travellers and goods to arrive for shipment on the eastern bank of Faversham Creek compared with the west. You would expect Standard Quay to lie on the eastern side, as indeed does the town as a whole. So, does the same apply to other towns in Kent? If so, you would expect them to lie on the eastern side of their respective waterways. All these towns should be, if you look at it from the point of view of an arriving vessel, left-handed. And this does indeed seem to be the case all the way along the North Kent coast. You might expect the same to apply on the northern shores of the Thames estuary. You would expect the towns in Essex to be more extensively developed also on the eastern bank. So is this the case? Here, the waterway network is a little bit more convoluted. But except for Malden and Dagenham is more of a conurbation, and it's hard to tell where exactly the town's developed in relation to its waterway. They've all developed, apart from those two, on the eastern side of their respective waterways. So from the point of view of an arriving vessel, they're right-handed. So it seems plausible that the creek has influenced the shape of Faversham in much the same way as many other ports in the Thames estuary. So let's leave the Thames estuary and sail up Faversham Creek a little way and see if we can pinpoint any particular concentration of people and goods that might have played a significant role in the town's development. And bridges and quays are a good place to look. Is there a place, historically speaking, that we can identify as the heart of Faversham? And I'm rather drawn to this location at Stonebridge Pond, which is the transition from salt water to fresh water, with the wharf, Ordnance Wharf, and two bridges, which rather suggests that for many centuries this area was the logistical heart of the town. So thank you for joining me on this journey. I hope you've enjoyed it, but there are still some questions that need answering.